Hello class, Professor Anderson here. Let's talk about escape velocity and what it would take to escape, say, the gravity of the Earth. Okay, so you know how to do this. If you're sitting here on the Earth and you fire off a rocket, it's going to go up to some height and then eventually it'll come back down. But what if you fire that rocket so fast that it just keeps going? Okay, it just keeps going away and never comes back at all. What is the required velocity to do that, to make that happen? Well, let's figure it out and let's attack this from the point of view of conservation of energy. Okay? Conservation of energy says the following. Whatever energy we have initially has to be there finally. And when we launch this thing and it's taken off at speed VI, it certainly has kinetic energy. But it's also in this gravitational field. And so there is potential energy. When it gets out to some distant location, it might still be moving. It might still have some gravitational potential energy. Okay? Let's put in these terms and then we'll see how we can simplify this. The kinetic energy right when you launch the thing is 1/2 mvi squared. What's the potential energy when we launch it? What do you guys think? Nassim, what do you think? What's the potential energy when I launch it?
Would be nothing initially on Earth.
Okay. Yes, if we're thinking about MGH. But we're no longer thinking about MGH because we are talking about very distant distances for both of these. And we know that the force is no longer constant as we do that. So we cannot just put in MGH anymore. We have to use the potential energy that we just solved for a minute ago with Newton's universal law of gravitation. And do you remember what that was?
Was maybe G-M-M over R.
Good. Negative G-M-M over R. Specifically, R initial. Where do we start from? Now, what about over here? Well, we still have kinetic energy, perhaps, potential energy, G-M-M over R final. And now this is where we're going to make some simplifying assumptions. Let's say that when we get out to this distant place, it is so far away that we can call it infinity. RF equals infinity. And we're looking for the smallest amount of speed we have to launch this projectile with, which means we don't want any excess speed at the end. So V final is 0. Okay. And if that is the conditions for this, look what happens. This term's going to drop out, and this term is going to drop out because we put RF equal to 0. And so now we get a nice new relationship here, which is the following. 1/2 m VI squared has to be equal to G-M-M over R sub I. And this thing is what we call escape velocity, this VI. Okay? And we can solve this equation for VI. What do we get? The little m's drop out. We multiply by 2, and we take the square root, and we get 2GM over R sub I, and we take the square root. And this is escape velocity. V escape is 2G big M over r sub I, but r sub I is this. And so that is the radius of the planet, and we take the square root. Okay, m is the mass of the planet that you're on. If it's the Earth, then it's the mass of the Earth. R is the radius of the planet. And if you launch a projectile with that speed, it will fly away and never come back. If it's anything less than that, it will go out very far, but will eventually come back. And if it's anything more than that, then it will launch out to infinity, and it will still have some excess kinetic energy when it gets out to infinity. When I say it's, what, say that again?
When you say never comes back, where it will stop?
We have no idea. Okay, so this is a good question, right? If things just go out there forever and they don't run into anything, there's a lot of other things out there to run into, right? There's asteroids, there's other planets, there's stars, there's black holes and so forth. But it will just keep going away forever. So let me ask you a question. Have we as humans ever done this? Have we ever launched something that has left the Earth and never come back?
Yeah.
Yes? What?
Yes, I like leaving the solar system.
Okay. Specifically what?
Which now it was?
Can you think of the name of one? There's a very famous name. Voyager. Yeah. Voyager, we launched from the Earth, and it is currently about to leave our solar system. Okay, it's gone past all the planets, it's past Neptune, it's nearly to the Oort cloud, which is what we call the edge of our solar system, and it will just continue to go away forever. And a simple way to think about it, it's a little more complicated because we did a slingshot around various other planets. But one way to think about it is we launched it with a big enough speed that it just left. It went away. Which is kind of cool, right? Thinking some other alien life form out there is going to come across this Voyager spaceship and discover something about us. And there's all sorts of information on that Voyager about humans, including pictures and music and math symbols and things like that, trying to tell them a little bit about our culture here on Earth. And that's kind of cool, I think.